Welcome back, guys. So, combustion analysis and the startup of a machine, they go hand in hand. Combustion analysis goes well beyond the startup of a machine as well. So, we have Tyler Nelson from Sauermann to talk about combustion analysis on startup and during commissioning. And this is a two-part episode. We're going to get to part one now. We're going to get Tyler. Tyler's very passionate about this trade in combustion, especially. So he's very knowledgeable too. So we're going to get to part one, and part two will be out in a few days, guys. Let's go. This is the HVAC Know It All podcast. I'm your host, Gary McCreadie. This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out. All right, man. So combustion analysis and commissioning of equipment. We can start maybe a few years back, or we can start now. Like, where do you want to start with this, Tyler?
I want to start a few years back. I mean, going far back enough, it started off with the back rack wet kits, and then it slowly migrated its way into electronic combustion analysis, electronic tools. And that's where we're sitting now. But we've seen significant advancements, not only in the technology that's within analyzers, but also with the way that the instructions being provided. Years back, it was the Jim Davises of the world that kind of started off. He's one of the OGs. He's one of the instructors at NCI, National Comfort Institute. And it started with them, where they were the crazy people in the park singing to the pigeons, or talking to the pigeons. Everybody thought they were crazy talking about combustion. Well, come to find out that they weren't. They were just far ahead of the curve. And there's been a lot of other trainers that have come on, myself and other trainers and other manufacturers that have done this now.
Can I make a statement there? Because you said that
Sure.
they sounded like he was crazy. And I just put out a meme on Instagram today, and it was literally along those lines. Every time a new piece of technology comes out, we have people on Instagram and TikTok and Facebook going, what a piece of shit. That's a piece of shit, junk. But they don't even know the product. They've never touched it. They've never seen it. They've never interacted with it. But this is like an emotional response.
Mm-hmm.
So it's funny how we get these quick emotional responses to things that are maybe new to someone. Instead of emotionally hey, listen, I'll take the emotional responses on Instagram any day because it helps with the algorithm, right? To show. But what I'm saying is, it's very interesting to see it happen. And then 5 to 10 years later, there's adoption. And you're like, hey, but weren't you just laughing at this 5 years ago or 10 years ago? So let's keep an open mind when we see these things. That's all I'm saying.
Yeah. One of my mentors had said to me a while back, he goes, this is one of the industries where we say, this is what I've been doing for the last 20 years. This is what I'm going to keep doing. And it's not the way that we should be looking at this. It's almost, when something new comes to pass, we almost should be vetting it and looking a little more into it before we turn a blind eye to it, or turn the other cheek and say it's not going to work. And we've seen it with instruction. Again, going back to Jim Davis and even Jim Bergman some years back, with the way that they were providing instruction, they were doing it and still do it for the betterment of the industry. They're not doing it to be popular. They don't even want to be filmed. They're just being filmed and being documented because of how effective they are. And now you have David Richardson for the NCI and the other instructors there. And then you have other instructors around the country that do it very, very well, that we all know who they are. And there's a place for all of us out there, and the education's increasing. Combustion, because we can walk away from a piece of equipment, Gary, and it runs, we think it's fine, but we don't know what we don't know. And this is how I liken combustion analysis. And it is very, very simple. If you go to the doctor and they never do your blood work, you do not know, and they do not know the proper true state of your health. You could look like an Adonis like you do now, a fashion statement like a model. But until they get underneath the hood and see your blood work, they can't actually tell what your state of health is. They don't know your cholesterol. They don't know your blood counts. They don't know anything. Now, combustion does the same thing. The equipment could look fine. It could be humming along and sound fine. But until we get under the hood and do the combustion analysis on it, we don't know how it's running. And we're putting these things, as we want to talk about commissioning, we're putting systems in mutually exclusive environments with different static pressures, different fuel flow rates, different appliances, different everything. But yet we're treating every patient by giving them an aspirin tapping them on the ass and telling them to go home. It doesn't work that way. We need to spend the time providing the concierge medicine type effect that we're doing on a system, like myself and the other excellent technicians out there. I just came back from HVAC Excellence, and that's the instructors out there. And there's a lot of very intelligent people, a lot of great speakers out there. And they're all treating this as if it's almost like a concierge type approach when they're working on a piece of equipment. When they touch it, they own it. And they need to make sure it is working fine from setup to breakdown.
Yeah, for sure. So let me ask you this question.
Sure.
Your opinion, or professional opinion, I guess we should call it. Every time you touch a gas-fired appliance, whether it be propane, natural gas, should you have an analyzer on it every time?
Yes.
Yes?
I'll tell you why. It's very, very simple. A combustion analysis is a snapshot in time. It shows the state of health of the piece of equipment and the way that you left it. If something happens after the fact, for example, say there's a CO issue in a house and you had left it 6 months ago, but say another contractor came in and did some work there and put in, maybe just replaced flue piping, and decided to put the high efficiency flue piping instead of terminating out the side of the structure up through the roof. And then a roofer comes in and cuts it off and then vents it into the attic because he thinks it looks poor. That's an issue where they can start to trace back, okay, if somebody gets sick from CO, who was the last people to work there? Your combustion analysis shows the state of health of that piece of equipment and the way that you left it, despite what happens after the fact. And you cannot control what happened before you got there. You cannot control what happens after you leave, but you can control your actions. And by doing that, you're going to avoid the Wanton Act. What the Wanton Act says, and that's WANTON ACT, Wanton Act says, is that if you knowingly or unknowingly leave a piece of equipment in disrepair, disarray, whatever the case may be, and somebody gets sick, dies, or gets injured, you're held liable. So your proof of the way that you left it to avoid liability is that combustion analysis, because as long as you're using a calibrated device, the results coming off that analyzer are true to form, and they show the true state of health of that piece of equipment.
Good answer. Now, what is the Wanton Act? I've never heard of that before.
Yeah, it's a legal act. I don't know if it's in Canada, but it's in the States here. Again, says it's basically malpractice almost would be in our industry, is if you leave a piece of equipment and you didn't repair it right, or you left it in a dangerous condition, and say I was working in your house and you got sick or your family got sick, I am held liable. You can sue me for that. So because we talk, a lot of the instructors now, we all speak about liability because we all speak also about CO safety. And we touch upon this because we don't want anybody to have ill effects after we walk out of a location. But it also ensures, if you think about it, reverse engineering to make sure the technician uses best practices. And part of best practices, at least in my humble opinion, is to use an analyzer every time you touch a fuel-fired appliance.
Okay. So I want to get into the conversation with commissioning and why it's important on startup as well, not just like service later on. But the Wanton Act you brought up, the reason I'm going to go down this route is because I've watched these conversations unwind or roll out on social media, and it along the lines of this. So someone finds a cracked heat, because here, like where I am in Toronto, Ontario, if we find a cracked heat exchanger, we have the right, not only the right, but the responsibility to shut that piece of equipment down, red tag it, our due diligence, all that kind of stuff. Now, I've seen these arguments, and I think these arguments came out of like New York State, I believe. Okay, I'm not picking on New York State, but this is where I believe people are, well, we can't do that here. We can't shut someone's heat off here. We're not allowed to do that. If we did that, we'd be out of a job. And these were the arguments that I've seen. So I don't know if they've got a governing body that says, hey, you find this, you shut it off. But apparently it's totally up to the homeowner if they want to keep it running. So is this Wanton Act, like, is it a federal thing or is it state by state? Like, what is it?
I believe it is interpreted state by state, but it is a general act. I don't know if it's at the federal level or not. I've only dealt with it at the state level, and I have attorneys in my family that I have discussed it with as well.
Okay.
So you have to know, in the States here, we have a very elaborate legal system, and to the point where I have contractors that I recommend create a red tag protocol. When they create the red tag protocol, of which I've advised many contractors on it, I also encourage them to rope in their attorneys or lawyers to make sure they're not doing anything they're not supposed to do. because some of the states or some of the municipalities say you can't shut somebody's system off. There's like protocols involved in all this. There, I essentially go by, 100 ppm or less in the stack under normal run cycle operations, what they call run cycle or steady state, is acceptable, which is 5 minutes or greater of operating time. And we can get into diagnostics in another podcast where we talk about the different rates and diagnostics related to those different firing times and everything else. But 100 ppm or less in the stack under normal or run cycle conditions is acceptable. 200 ppm or greater is a potential red tag situation. 400 ppm or above is an advice to lockout, which means I'm shutting your system down. I'm going to red tag it and dismantle it so you can no longer use it. Now, this is where we run into the gray area because you have to, again, I don't give legal advice. I encourage everybody listening to run this by their attorney to find out what are the limits. And then what you have to do is almost like set up a checkpoint system where you're advising the homeowner or the business owner, your customer, to say your customer, what you're doing and why with all of the proof. And that you're going to dismantle, we're going to render the system inoperable. You're going to decommission it. That is what we're supposed to be doing. I've seen it get borderline violent before when somebody went to shut somebody's system down, or the issue that bitter pill of we have to red tag it, because normally when you red tag something, Gary, it's thousands of dollars to replace it. Sometimes people don't have those cash reserves or credit or whatever, so it's a sensitive issue. So again, I encourage everybody to also use proper bedside manner when telling a customer this because it's sensitive. But it's up to each individual company to have their own red tag protocol, but follow, if there is a federal mandate like there might be in Canada, or there is in Canada, I believe, follow the federal or the governmental mandate, and then also whatever the state level is as well. Make sure you're kind of blending all that together to keep yourself out of that liability side of things, because you don't want anybody to die. That is the most important thing.
Yeah, we have a governing body here called the TSSA, and
Mm-hmm.
and they basically tell us how to operate when it comes to this kind of stuff. And they're actually not a government entity; they're actually private. So it's interesting how things are done different places of the around the globe. So anyway, I want to ask you this before we get into commissioning of combustion. How did Sauermann get into the combustion analysis market anyway? Because you guys now have your own combustion and analyzers, right?
Correct. Yes. We had a previous analyzer that was made for us by a third party for a number of years. And that we, back in 2019, roughly going into 2020, severed that relationship or ended that relationship, I should say, because we're going to come up with our own analyzers. And what we did is we looked at the market and we looked at what we liked about our old line that we were carrying, which was a great line, what we didn't like about competitors' line that we competed against. In other words, where their flaws were some of our own flaws as well, which was not many, but where some of our own flaws were with the line that we were using at the time. And we decided to take feedback from anybody that's in a position like myself and others within the company, feedback from them as far as features we wanted to see. So we had a wish list, and they went after it very hard. They were steadfast on giving the industry what it wanted. And so that's how we got into it. And we wanted to get into, freshly get into the tool side of things. We had a footprint in the industry with our condensate pump side of things, tank pumps and mini pumps and that kind of a thing. So the easiest way to round out a portfolio is to do that. We had bought an instrument company a while back called Chemo, of which we obviously still have. And that is now really getting out into the marketplace full force here in the States and Canada here shortly. It's been over in Europe for a while, but we're starting to meld more of that into our process here. We have a new manager for that line of the business. So we're getting involved in that. But from a combustion standpoint, again, it was just simply round out the portfolio. And now we're getting further down the line with this because coming in the next few months here, we are launching a new wireless manifold and probe set, which will down here in the States and are using in Canada, but will also be on MeasureQuick, because our combustion analyzers are the only analyzers on MeasureQuick. And then we'll be sharing a space with other probe and wireless manifold manufacturers, and we're going to be on the MeasureQuick platform. So we have to have some pretty good chops to get on there, especially to be the only analyzer on there. So it's important to us. So we've listened to the customer. We watched what the industry was doing, kind of took a step back and watch approach, and then decided to not dip our toe in the pool, but actually jump on the pool and make some noise, which we have done. Hence the incredibly growing popularity of the line and the business.
So, yeah, so you didn't walk into the pool and let the water hit you inch by inch. You cannonballed in. It sounds like it, right?
We did. We did, and we got very lucky with it because we have features that are exclusive or that were caught the eye of the industry, where we have the longest sensor life, 5-year oxygen sensor, 4 to 5 year CO sensor life indicator. So you see how much sensor life you have left, because that's one of the Achilles that's been with analyzers, that you never knew when a sensor was going to die. We've eliminated that issue. You see how much sensor life you have left. We have an algorithm built in there that looks at not only just time, but also looks at usage. So we it's all calculated in there. We also have end of life. So if you forget to look at the sensor life indicator, the end of life indicator protects you. And then we have such things as seal pump cutoff, so you can vary that rate, and other features in there as well that have been class leaders for us.
All right. So I guess my next question is, because you have the 5-year sensor and you have the sensor life indication, do we need to calibrate these things on a yearly basis, or we follow what the sensor's telling us at the?
You need to calibrate, and here is why. This
Okay.
comes down to me when I talk to my audience, as I say to them very simply, you have to eat your own dog food. What does that mean? You have to take your own advice. You want your customer to call you spring and fall for preventative maintenance. This is that. You're sending it once a year, because when we calibrate your instrument, we issue a calibration certificate. That calibration certificate is good for 1 year. We are an ISO lab, NIST traceable lab. So when we issue it, it says that any readings coming off of that analyzer for the next 364 days, because it lasts for a year, for the next 364, are valid and legal, which means they can be used in a court of law. So not only do we calibrate it, but that certificate is issued. But we don't stop there. So myself and the other very good instrument manufacturers out there do a full-blown service on it, which means we rip the instrument apart. We pressure test the probe and hose assembly. We check the water trap integrity. We check the screen integrity. We check the manifold. We check everything, and then we calibrate it, and then we kick it back to you as a finished product. So everybody should do it once a year, because it's yearly maintenance. That's how I want you to look at it. And that's a
Okay.
perfect world, Gary. That's a perfect world.
Yeah, no, but it makes sense, because if it's only valid for a year and you do have legal issues down the road, at least you're keeping up to date with your maintenance of your tool. Anyway,
Right.
so let's get into some commit. You can like spit out features like of the analyzer sort of as we weave it into the conversation if you
Sure.
want to. So commissioning. Now, you can tell me what you think of this. Commissioning, I had a long podcast conversation one day with Tony First, who hasn't been on my podcast in a while. He moved on from the place he was prior. But Tony, being an engineer and being in big projects, like high-rise projects that take a while, the way he laid out commissioning was commissioning starts when the project starts, basically. And startup is the day you go to start the machine up. So when we say commissioning, I just want to get your take on commissioning. Commissioning to you is the day you start it up, or is the process as you're installing, checking this, checking that, checking this, and going back and going through your checklist of that's commissioning to me, and it makes sense the way Tony says it. Then we get to the startup day, we turn the machine on, our analyzer's in there, and we're going to fire it up and see how it runs. Just give me your opinion on that first before we.
My opinion is very similar to yours, because here's why. Especially when you're talking about, at least in a residential application and also some commercial, you're dealing with a condensing system. One of the things you need to verify is that you have proper fresh air intake coming back to that system. This is before you go to even fire anything up. I mean, you're going to fire it up, but you need to make sure your venting is correct. Now, what I encourage people to do is to turn on any fuel-fired appliance in that establishment, because I want to make sure that I have no migration of another appliance's flue properties making their way into my fresh air intake when my system is going to run or is running. Because here is why. As your body is designed to receive or ingest or take in 20.9% oxygen for its breathing process, the HVAC systems we're installing are designed to ingest the same. It operates like a body does. They're designed to take in 20.9. Anything less is cross-contamination or some form of recirculation, which means you are now bringing in potential NOx, other acidic properties, carbonic acid, other chemicals or other byproducts out there from the combustion process going back down in that system. And NOx is an acidic, poisonous gas. It eats whatever it touches. So you're going to see things start to eat away at the mechanicals. And it's going to start to put a strain on the system, and it's going to cause mechanical failure, rust, and those kinds of things, high moisture content, all that other stuff, if you don't have proper fresh air intake. So that's just out of the gate. And now, another thing, you know this as well as the rest of the audience. We should be checking static pressure. We got to be checking static pressure with what we're doing, using a manometer to do that. That's part of the commissioning process, is gathering all the facets, Gary, to have a body function in a healthy manner, except we're talking a piece of equipment. So that is proper intake air for proper breathing, proper venting, making sure those two things aren't too close together. I know everybody thinks they're as smart as they think they are, and I'm sure they are, but there are forces fighting against you. And again, those are other appliances. We're also paying attention, Gary. If someone's venting something out and there's a bush here, so if the fresh air intake is here, or the flue exhaust is here coming out, if it bounces off this bush or the shrub and the fresh air intake pulls it back in, that's an issue. We need to make sure that those things are proper, and that goes into maintenance too. And we'll get into this on another podcast, but with maintenance, shrubs grow up. People put in other small structures. People do things landscaping wise that can impact how a system vents, or put in other appliances that can impact how a system not only vents, but takes in its fresh air. So that is something out of the gate. So it doesn't just start when you're firing the system off. That's when the analysis comes of the blood work to see what you need to do for your new patient, and to see what adjustments, if any, need to be made. And it's a crapshoot of whether or not technicians are installing things that are underfired or overfired. I have seen both in application. We do work for a very, very elite contractor here that has bought up many other companies like Pac-Man. And sometimes they change the name of them to their name, sometimes they don't. Well, this was a house system that they had installed back in June, and I was there in November. Well, I just did a in-person class portion that we're doing hands-on or live fire. Well, when we went to go do live fire at steady state, or what they call run cycle operating times, which is that 5-minute sweet spot roughly and greater, the PPM for the CO air free was over 167. So that's an issue. And the oxygen was 2.8 or 2.7. So we looked at it with the manometer function, and it was 4.6 or 4.7 inches of water column. So, okay. And I would normally have people step it down in increments. We know we need to get to 3.2 to 3.8. I would normally step it down in increments just for the learning exercise. I said, no, this is so atrociously bad. I said, bring it to 3.5 and watch everybody look what happens. Brought it to 3.5. CO went down like 16. Oxygen jumped up like 7.2, 7.3. Everything was stabilized. But I said, I looked around at the whole group behind me, and I said, if anybody here thinks now that you don't need to use these for commissioning, you're mistaken. I said, and this is your house system. They had no idea that it came in that way. And it was a learning experience. And I've seen them come in underfired. I've talked to a lot of equipment manufacturers, a lot of engineers, and they say they purposely send things out underfired because they don't want the liability. In this case, for this specific example, it was an overfired one that I was dealing with most recently back in November, but I have seen it all over the spectrum.